sessions. I'm turning the recording on now. And just for your info, that control panel that you're looking at, the GoToMeeting control panel, you want to minimize that so that it doesn't take up so much of your screen. Next to the X in the upper right are two little arrows. If you click on that, it minimizes it, and it's like a toggle switch. You can bring it back up again by clicking on the same two arrows. So, tonight, what do we have? Do you have stuff you can verbalize or not?
It's an online thingy. Like, it's online. It's Math Excel.
Well, there's two ways we can do the online. One is that I can pull that site up on my screen. You would have to give me your username and password, and I would enter it, and then we would both be looking at it, the same screen. And when we go to answer the questions, I would do it on my end. Okay? The other way is for you to just read the problem that you're looking at to me, and I'll write it, we'll figure it out, and then you can answer it on your end. It just all depends. Now, GoToMeeting also has a third option, which lets me make you the presenter, so that instead of looking at my screen, we're looking at your screen. So if all of your problems are coming from the online site, even the ones that are graphical in nature or ones that would be difficult for you to verbalize, we can do it that way. I can just turn on you as the presenter, and then I would be looking at the same thing you're looking at.
Can we do that one?
Yeah, let me do that right now. I will make you the presenter. So, let's see, it's been a while since I've done this. Make presenter. You're going to get a request to be the presenter.
Does I have to download a small extension?
That's because I noticed that when you logged in, it says web.
Should I just give you my username and password for that?
That might be the easiest thing. Hold on, let me go back and make me the presenter now. So yeah, why don't you do that? Hold on, let me open up my browser.
Then it's Math Excel for School.
I think I have this saved. Math Excel, where is it? Come on, I know you're there somewhere. I know I've had this on here. I don't know why I can't find it. Maybe it's, let me type it in. This one here?
Yes. Okay. And then
tell me what to click on next.
The sign in button.
Okay. Now, you can, if you like, might be easier, if you open your GoToMeeting control panel. Notice down where it says chat.
Yes.
Okay. And where it says enter your message.
Yes.
Type your username and password in two separate lines there, and then I'll just copy and paste them. Now you have to type it in and hit enter, and then it shows in the chat window, and I can copy and paste it. So it's Stacy or
that's a 5. So L5.
L5. Okay, that's your username?
Yes.
Okay, let me put that in there.
And
hold on, my browser doesn't allow pop-ups. Hold on a second. That's okay, I don't need a pop-up for this. Okay, And then your password, go ahead and, okay, I got it. I hate Math Excel, actually.
Yeah, it's really difficult.
Well, boy, if you don't put it in just exactly the way they want it, it just creates frustration upon frustration. Okay, what should I click on here?
It's under Monday, I think.
Okay.
And then 2.6 rational functions.
Okay.
And
Question
all those
one?
questions. Yes.
All right, so we're talking domains and ranges.
Yeah.
What does domain mean?
It means X.
All of the allowable values that you can put in for X.
Yes.
Is there any restriction on what I can put in for X if I'm making up numbers?
Negative 14.
That's
right?
the only one you cannot put in. In other words,
Yeah.
every other X is fine except negative 14. That causes division by 0, which is, of course, the first rule you do not want to break. So the answer clearly is A, not B. And this answer says that X is all reals except, and this is where I put in negative 14. Hold on.
Negative. I don't want to make it bigger. So, where?
Okay, should we go to the next one?
Yes.
Okay. Okay, you have to close yours out. I've run into this before. Is yours still open?
No, I just closed it like before the first problem.
Huh. Okay. Let me back up here. And maybe it was detecting yours was open at that point. Hold on, let me, well. Is this problem 1 again?
Yeah, but it's different.
It is different. Okay, well, let me answer it.
Negative 13?
Negative 13, right. Now, let's see what they say now when I hit enter. Okay.
Okay, no.
Now we're in business. Okay. All right. Here, what is the domain?
So it can't be 5 or negative 6?
That's it. In other words, there's no restrictions from the numerator at all. It's only, in these problems so far, it's only the denominator. So it cannot be 5 comma negative 6. Okay. How about this one?
Does that say x squared plus 5?
Whatever, here, let me minimize this for a moment. In fact, let me bring up 2 different things here. That snap left, this snap right. It's whatever makes the denominator 0, right?
Yeah, but nothing squared is
Exactly.
a negative.
You can't take a positive number and add a positive number to it. There's no way that's ever equaling 0. So therefore, there's no restrictions on the domain here. X can be all real numbers.
Okay. So B.
Yeah. I love their fantastics. Great job.
Use the graph of the rational function to complete the following statement.
Okay. So as x approach, you know what that means there? As x approaches -3 from the left, what is the function approach?
-1?
No, the way you do these, here's -3, this dotted line. Can you see my cursor?
Yes.
Okay. See that dotted line at -3?
Yeah.
Well, we're going to approach it from the left, but we approach it by hopping on board the function. Okay? So I've got my cursor on the function, and I'm approaching -3 from the left. What's happening to my cursor? Where's it going to end up?
Up. So infinity?
Positive infinity.
Positive infinity.
How do I put that in here?
Sometimes there's like a...
Yeah, there's a table thing, isn't there? Yeah, hold on.
Yeah.
Where they let you choose from a series of symbols.
Yeah. It's usually on the bottom.
Click your answer in the answer box and then check answer. Check answer. I don't see anywhere in here all parts showing. I don't know what that means. I don't have an infinity symbol on my keyboard. So how would you put that in there? Do you know if you were logged in?
Yeah, usually there's something in the bottom that has all the symbols, but I don't see it on your screen either. I don't see it
on my screen either. Question help. Textbook? No. Help me solve this? No. View an example? No. I don't think we want that. Let me hit this. On-screen keyboard. I didn't see an on-screen keyboard come up.
It was on automatic when you pressed OK. Maybe press on.
Oh, okay. I got to press on.
Got it. What?
Still didn't see one.
We can pass this problem and then I can go back on it later and put it on.
Okay, when I turned it off, that didn't seem to help either. Let's see what happens if I blow up the graph a little bit. That doesn't help. But these are key questions. In other words, I didn't realize you were into limits already. Did you just start limits today?
No, I remember doing this last year.
Okay. Well, the key is always to be on the function. And what you're doing is approaching the x value from either the right or the left, and whatever the function is doing. In other words, let's examine the second part of this. As we approach, now we got our keyboard. In other words, I had to click on the bottom part. I was trying to click up here.
Oh, okay.
Click down there, and that actually opened it up. I'm going to put infinity and then enter. All right, we got it figured out here. As x approaches negative infinity, what does f of x go to?
So as x approaches negative infinity, positive infinity.
No.
Right? Wait, no.
Get on the function. In other words, put your pencil on that function and start approaching negative infinity. What's happening to the y value? It's getting closer and closer to what?
0.
That's it.
Oh, right, but it never touches 0.
Exactly. I'm assuming I can type in 0 there. Yeah, okay. Okay, this one says, as x approaches 3 from the left, well, the 3 is the dotted line on the right. We're going to approach it from the left. So what's my function doing as I approach it from the left?
Fx is going to negative infinity?
No,
right?
Approach it from the left.
Left.
Positive infinity. If you were approaching it from the right, here, let me blow this up. I think it maybe helps, especially if you can see my cursor.
Okay.
Okay, there's 3. I'm going to approach it from the left. So I hop on board the function. I'm going to positive infinity, right?
X goes to 3. Oh, okay, yeah.
Okay. Now, if I were to approach 3 from the right, you would be correct. We're going to negative infinity.
Looking at the wrong function, I think.
What's that?
I was just looking at the wrong function.
Oh, okay.
I was
So my next question is, what is the limit at 3? Does not exist.
Because it never will touch the 3.
There's only one rule that calls for a limit to exist, and that is that its limit has to be the same from the left as it is from the right. Then it exists. Well, in this case, when we approach it from the left, we're going to positive infinity. When we approach it from the right, we're going to negative infinity. Therefore, it does not exist at 3. And that would be the answer. In other words, if they said, what's the limit at 3, it would be doesn't exist. Well, let me put in positive infinity here. See what their next question is for this one. Okay, here as x goes to infinity, what does the function do?
X goes to 0? Wait, no, -1. Is that a -2 or a negative?
-2. In other words, it approaches that horizontal dotted line, right?
Yeah.
And that's -2. Okay, find the vertical asymptotes. If any, and the values of x corresponding to holes, if any. All right. Let's talk about this. Let me shrink this up a little bit and put it on the, oops. Come on, that doesn't, there we go. When you have a function, normally the very first thing you're going to do is figure out what makes the denominator 0, right? Mm-hmm. That's usually your vertical asymptotes. In other words, if I had 1 over x plus 6, my vertical asymptote is at -6.
So there's one at 0 and there's one at -6.
Well, normally there would be. But in this particular case, you can divide top and bottom by x. So this function actually turns into this. But instead of a vertical asymptote at x equals 0, we have a hole. Whenever you can factor that what would have been a vertical asymptote out of top and bottom, it leaves behind a hole. In other words, it's not quite exactly that. It still has the domain restriction that x cannot be equal to 0. That does not disappear just because I divided top and bottom by x. So I have 2 things going on with this function. I have not only can x not be -6, but it also can't be 0. So however this function looks, how about a horizontal asymptote? Where's that?
Let me. Oh, I can't remember.
Horizontal. There's three rules that you have to remember. If the highest degree in the numerator is the same as the highest degree in the denominator, then the horizontal asymptote is the ratio of their coefficients. Okay? If the bottom is bigger, the horizontal asymptote's always at x equal or y equals 0, excuse me. Okay?
Okay.
And in this case, the bottom's bigger because if we multiply this out, we have an x squared, and the top only has an x, so the bottom's bigger, automatically making the horizontal asymptote y equals 0. Now, if they were the same, the horizontal asymptote would be whatever that ratio is.
Oh yeah, you put the, I remember, you put that over the other one.
If the numerator is 1 degree higher than the denominator, then you do the division first and you work with the remainder. So those are the only 3 situations you're going to have to know.
So if it was like 3x over x, it would be 3 at 3.
Yes, the horizontal asymptote would be y equal 3 if you had 3x over x. But in this case, you don't really have x over x, you have x over x squared.
Yeah.
So the horizontal asymptote is 0. Okay, now once I've drawn my grid, my vertical and horizontal asymptote, well, I know what this function looks like. It's hyperbolic, so it basically looks like this. In other words, it's asymptotic to both of the asymptotes. Whoops.
Yeah.
Didn't mean that'll never touch that asymptote, but it'll approach it. And the only thing you have to kind of make sure is if I'm in the right quadrants. I've graphed it in the first and third quadrants, okay? And some of these hyperbolic functions end up being in second and fourth instead. So let me check. If x is 0, even though I know it can't be, but if x were 0, my y value would be 1/6. So that tells me I'm in the right quadrants. Now, let's talk about if x is 0. That leaves a hole right there. And that's how you graph that function.
Okay.
X cannot be -6 and it cannot be 0. It's undefined. The function is undefined at both of those places.
Okay.
Okay. So let's start answering the questions here. Let's see. So the vertical asymptote is?
Oh, we choose one of those.
Choose. Oh.
I think it's
C.
C.
Yeah, I see. Okay, they're not 4 separate questions. Yeah, the vertical asymptote and hole. Okay.
Yeah.
So the vertical asymptote is at -6 and the hole is at 0. Uh-oh. And the thing that I never know here is, did I accidentally put in an O or what?
There are no vertical asymptotes. There is no vertical asymptote. There are no holes. There are no discrete.
Well, it's not A because there's a hole at 0.
Yeah,
Not
and then
B because there's a vertical asymptote. It's got to be C. It certainly isn't D. A discontinuity is anytime you have to pick up your pencil to draw it. That's a discontinuity. That's the definition. So it's got to be C, so I'm just not putting it in here right. Let me try putting it in one more time.
Vertical asymptote.
-6. That's what it looked like before. And I know I put in 0. And
I'm not sure why it's not working.
no, that's the problem with these. It's not the first time I've run into this. Trust me. These give me an anxiety attack every time I work with Math Excel because it's so hard to figure out what you're doing wrong. And you only get what, 3 choices? 3 chances?
Yeah.
So now what? Should we do a final question help or? Let's
see.
Fill in the answer box. Type an equation. Ah.
So X equals?
X equals, wow.
I think that's what it is.
So X equals -6, and the holes are at X equals 0.
Hopefully this is it. Oh, wow.
That'll drive a person to drink.
That's why I hate Math Excel.
I do too. I do not like Math Excel, but you kind of get used to it, and after a while, it's just that you run into problems like that where the instructions are so unclear. Now, let me shrink this up a little bit so we can look at this next function. Hold on. This next function is x squared minus 16 over x minus 4. Again, if you didn't examine it very closely, you'd start out saying there's a vertical asymptote at 4. But always think factoring when you're doing these. Can you factor the top?
Yes, so it's x plus 4, x minus 4. And then we can cross out the x minus 4.
As long as you realize that you still have to carry forth that domain restriction. X cannot be equal to 4, even though this function becomes x plus 4. And if you look at just the function, it doesn't look like there's any domain restriction there. But if we were to graph that function, straight line goes through 4, has a slope of 1, but there's a hole right there at 4. Now, if you go into your calculator and you type this, it will not show you that hole.
Okay.
The reason is because that hole is infinitesimally small, right? It's only 1 point on the number line, and that's at 4. And there's literally an infinite number of points between 3 and 5. So you would not expect the calculator to show it because it's so small and tiny that it can't show it. And it doesn't have the brains to put a hole in there, to understand the math of it. At least, do you use the Inspire or you had TI-83, right?
Yeah.
Okay. I know the TI-84 and 83 does not show it. Whether the new Inspire shows it, I doubt it. Even Wolfram Alpha. Are you familiar with Wolfram Alpha?
Yeah.
Great online math resource.
Yeah.
If you type this into Wolfram Alpha, it does not show you the hole. It may list it with its information at the bottom, but it doesn't show you the hole. So let's see, which answer do we need here? We got no vertical asymptote, but there's a hole at x equal 4. X equal 4.
You need the x equals or?
Oh, no. Wow, you're kidding me. They change up the instructions problem to problem? You're right. Well, I just noticed that the x is already there.
I don't know why they do that.
Wow, I guess they really want you to read the question in detail, huh? Both times I didn't read it closely enough. All right. This time we have x minus 9 over x squared minus 81, which factors into what?
X minus 9 over x plus 9.
Yeah. There's actually a reason why I always write the negative first. And that's because, have you had to memorize the difference of cubes and the sum of cubes?
No, I don't think so.
Well, there's a pattern to all three of them. There's a very similar pattern to difference of squares as there is to difference of cubes and sum of cubes. And the pattern is that the first term always has the same sign. So that's why I list the x minus 9 first. It's because that agrees with the x squared minus 81. And that same pattern exists for sum of cubes and difference of cubes. And so I like to use the same pattern for everything because it really makes it a little easier to memorize.
That makes sense.
Yeah, okay. So here I can do that knowing that I'm left with this with an additional restriction that x cannot be equal to 9. And not because of the final function, but because of the original function. So what's the answer here?
So there is no vertical asymptote.
Hold on. Hold on. We still have that. In other words, after factoring and canceling, we still have 1 over x plus 9. So there's still a minus 9 that is a vertical asymptote.
Yeah, x cannot equal 9. Negative 9.
X cannot equal negative 9, and there's a hole at x equal 9. So there's a vertical asymptote at
negative 9.
Negative 9, and there's a hole at x equal 9. All right.
Wait, no.
Let's have a look at this one. 13x over 3x squared plus 2. I don't see anything that's factorable. Any vertical asymptotes?
No.
No, because the bottom cannot be 0. There's no way that 3x squared plus 2 can be equal to 0. Therefore, the domain is unrestricted. There is no restrictions at all. They're asking about the horizontal asymptote. Sorry,
Yeah.
I didn't read the directions. Where's the horizontal asymptote?
You do the third over no because the bottom is...
Because the bottom has the higher degree, the horizontal asymptote is always that.
Yeah.
If it was the same, if this was x squared, then the horizontal asymptote would be 13 divided by 3. But as long as that's x and this is x squared down here, then it's always y equals 0. And this one they do want the equation. It's y equals 0.
Okay. So this one would be 16 over 6. So
16 over 8.
is that an 8? Oh.
That's an 8, yeah.
Okay.
I could probably blow this up if I looked around.
So just
how to
2.
So
X
y equals.
I mean y equals 2.
Horizontal asymptotes are always going to be y. And notice that nothing else matters. That could be a plus 1. It could be a plus 1,000. It could be a plus x plus 1,000, and it wouldn't matter. The only thing you care about is the highest degree.
Okay.
That's it. Okay. All right. When you have the numerator exactly 1 bigger than the denominator, you end up with what is called an oblique asymptote.
Okay.
Okay. And you get the oblique asymptote by doing the division. 8x squared plus 3 divided into 16x cubed, and the equation of the oblique asymptote is whatever you get ignoring the remainder. Doesn't matter what the remainder is. It's this linear function that you start with. Well,
that would be 2x.
correct. Now multiply. So you get 16x cubed plus
6x.
6x. I've got a dummy variable there, plus another dummy variable for the x squared, x. Let me think for a moment. That's it, right there. The oblique asymptote is 2x. Hold on a minute. Find the horizontal asymptote, if any. Well, the horizontal asymptote is going to come from that remainder.
Okay, so we do need to find the remainder?
We got to do this whole thing.
Okay. I remember this long division.
It's brutal. It's brutal when they do it like this, because for some reason, what was it, 8x squared plus something? What was the number?
6x, or shoot.
Hold on.
6x?
8x squared plus 3.
Oh, x.
We're dividing into 16x cubed. Now let me put all these dummy variables in there and see if that helps. So first I divide that into that. I get 2x. And then I multiply that times everything.
So, plus 6x plus 0.
Well, that's all at the moment. And now if I subtract, I get minus 6x. So looks to me like the remainder is minus 6x divided by 8x squared plus 3. Okay? This is the oblique asymptote.
Okay.
In other words, there would be a dotted line that has a slope of 2, not 1, like I was drawing it, has a slope of 2 that would represent an oblique asymptote. In other words, the function as it goes to positive infinity is going to approach that oblique asymptote. But the remainder doesn't disappear. That has a horizontal asymptote where?
Negative.
Now the bottom's bigger than the top. Always y equals 0. Okay, so I'm nervous about this one, but I'm going to pick it.
Y equals 0.
Yeah, it's either that or B, right? So we can't go wrong. Y equals 0. Let's see if it likes that one. No. Find the degree of the numerator and the degree of the denominator, then use rules for locating horizontal asymptotes. I must be wrong on this. It must not, in other words, there is no horizontal asymptote based on that remainder. Okay, well, you learn something new every day.
No, okay.
Had you been taught about oblique asymptotes?
I don't remember going over that
Well, you only get the oblique asymptote if the degree of the numerator is exactly 1 greater than the denominator. And then you do it this way. You divide it into it, and whatever the linear function is, that's the equation of your oblique asymptote. I wasn't totally sure about the horizontal asymptote. I thought it came from the remainder, but apparently this remainder is immaterial. There's nothing about it that is interesting. The only interesting part here is what the main part that came out, which was 2x. And that's the equation of the oblique asymptote.
Okay.
All right. Well, we'll know for the next one. Huh?
It's the transformations of x to graph. All right, so it's down 6 and then right 2.
Correct. Because so what we're looking at, it's important perhaps to understand. You understand these transformations pretty good?
Yeah.
In other words, what we're really looking at is f of x minus 2 minus 6. And that's where you get your transformation to the right by 2 units and down by 6. So which graph is that? C. Yeah, okay. It's the transformation here.
Down 7 and then...
Yeah, well, I think the parent function here is 1 over x squared.
Yeah.
1 over x squared looks like this. So it's this curve down 7 units. Okay, so D is the correct answer. However, before we leave this, let's talk about limits here.
Okay.
As I approach 0 from the left, what is my limit?
0 from the left, the limit is positive.
Correct. What is it from the right?
Positive infinity.
Ah, therefore the limit does exist because they're the same. So to me, the limit is positive infinity, although you'll still get some math books and math teachers that will tell you this limit does not exist because they frequently use the words does not exist and infinity interchangeably. But they're not really. In other words, there's a big difference between this picture and your regular hyperbola, where in one case the limit was positive infinity, from the other direction it was negative infinity. Clearly that does not exist by definition. If they are not the same, then it does not exist. Well, these are the same, so it exists. Now, what it is exactly, I'm not sure, whether it's infinity or whatever they want to call it, but it exists. But let's go ahead and answer that.
Graph the rational function into parts 1 through 7.
So when they say graph it, do they mean manually or on your calculator or?
There should be a graph on there if you open it to the full screen, I think.
Okay. Well, first of all, let's talk about it. We can graph this manually. Do I have a vertical asymptote?
Negative, wait, x minus 3.
Okay. Do I have a horizontal asymptote?
6.
Correct. So there's our grid, and we know that the thing either looks like this Or if I'm in the wrong quadrants, it looks like this. In other words, it's a basic hyperbolic function. Now, how would I tell which one I have?
Is it because if it's positive or negative?
Well, we need to plug in a number. In other words, if you plug in something to the right of 3 for x, you'll be able to tell whether the answer lies above 6 or below 6, right? So plug in 4 for x.
Okay, so what's 24 over 1 is 24.
This is our correct picture then.
Yes.
Not the red.
So select the symmetry function. The function is symmetric about the y-axis.
Function is not symmetric about the y-axis. I can't take the top and flip it and have it look exactly the same. It's not symmetric about the origin.
So the function has no symmetry.
Correct. There's only 3 kinds of symmetry, well, that I know of, and that's the x-axis, the y-axis, or the origin, when they're talking symmetry of these kind of functions.
Okay.
What is the y-intercept?
6.
That's this point right here.
Oh, right. That's the, so it's never touches.
What's true about the y-intercept? What's true about x?
It equals 0 when it...
Correct. That's a big thing to remember. Y-intercepts, x equals 0. X-intercepts, y equals 0. Always remember that. So to figure out the y-intercept, just plug in 0 for x, and what do you get?
0 over -3. So there's...
So 0.
Y. 0.
So 0. So my picture must not quite be right. That thing has to go through 0.
Yes.
So it looks more like that. Okay, so the y-intercept is 0. Part 3, what is or are the x-intercepts? Well, that's where y is equal to 0, right? Well, what makes a rational function or quotient, a rational function equal to 0? Only if its numerator is equal to 0.
Okay, so...
The only way this thing is equal to 0 is if 6x is equal to 0, which means x is equal to 0. And there's only one of them. In other words, the upper right hand doesn't go through the x-axis.
What is the x-coordinate of the vertical asymptote?
What is,
There's...
well, that'd be x equals 3.
Where's the coordinate?
In other words, they're talking about this point right here.
Okay.
Okay. So the x-coordinate is 3.
Oh, okay, yeah.
Select the correct choice. The x-coordinate of the vertical asymptote is 3. What's the y-coordinate of the horizontal asymptote? What's that?
There
is one, because that's what that dotted line means.
Okay.
That's a horizontal asymptote. Remember, it was the ratio of the coefficients, because the Yes, the highest degree in the numerator is x to the 1. Highest degree in the denominator is x to the 1. So the horizontal asymptote is the ratio of that, which is 6. And how do I have to answer it here?
I think just the 6.
6, I think? We'll find out soon enough, huh? At least they give you multiple chances.
Yeah.
What did they give you? 3, right?
Yeah.
Type the y-coordinate for each of the following points. Well,
so we just got to plug it in.
Yep. So what's the first one?
Negative 24 over negative 7.
Reduce it. (24/7). That's a positive 24/7.
Yeah.
Now, getting that in there ought to be a real trick. 24 divided 7.
Oh, yeah.
Like that. Should we try that?
Yeah, and then...
Oh, I got to answer the other 2 before I can go on.
So 12 over negative 1, so negative 12.
Okay.
And then 30 over 2, so 15.
Okay. Great.
Right.
And part 7. Using the information, which graph is correct? Well, we've already kind of graphed it, so
Yeah.
which one does it look like?
D.
Yeah.
That was a long problem.
It was. Yeah, it's hardly fair to even call that just one question, huh?
Yeah, that was 7.
There weren't 20 questions here, there were 26. Graph the rational function. Okay.
So
what does that simplify? Tell me what's going to happen in this function. Am I going to have any vertical asymptotes? Am I going to have any holes?
y equals 0 for the egg.
Well, first of all, let's reduce the function. Factor the bottom.
X minus 6x plus 6.
So the function ends up being 1 over x plus 6 with a hole at x equal 6. Okay? So 1 over x plus 6 is certainly not C or D. C, incidentally, has one of those horizontal asymptotes on it.
Yeah.
D has 2 vertical asymptotes.
Mm-hmm.
You'll see, we have a vertical asymptote at negative 6 and a hole at plus 6. Got to be here, doesn't it? Do I need to blow these up to see the scale? I don't think so. I think A has got to be right.
Yeah.
And that was only one question?
Yeah.
All right. This is probably a fact. Ooh, it's not going to be. I was going to say almost certainly one of the factors has got to be x minus 5, but it's not. Ah, here we go. Find the slant asymptote. That's what oblique asymptote means, the same thing. Something called slant or oblique. Okay, so here is where we divide. Because the numerator is exactly 1 degree higher than the denominator. So help me with the division.
One would be x.
Okay, and then x squared minus 5x. What's now?
Is that negative 6x now, or
now you're subtracting positive 4x.
Okay.
Okay, so
then
now I bring down the 12 and repeat.
4.
And there plus 4. And now that's the equation of my oblique asymptote, because everything else is just a remainder. In other words, here, your remainder is 8 over x minus 5. So x plus 4, y equals x plus 4 is the equation of the slant asymptote. More multiple questions. Use the slant asymptote to graph it.
To graph it.
So if x plus 4, and we know now that there's no vertical asymptote, there's no horizontal asymptote. There's only the slant asymptote, which goes like this. Got a slope of 1, goes through the y-intercept of 4. First, determine the symmetry. Okay. You see what down here for A and B are?
Yeah.
A is an even function. In other words, if you substitute minus xn for x, do you get the same function? Well, in this case, you don't. In other words, if I do minus x squared minus a minus x minus 12, and in the bottom I put in minus x minus 5. Now we simplify all of this. I get x squared plus x minus 12 over minus x minus 5. Well, that's not the same function at all. So it's not even. Okay? Now, B is odd, meaning if I put in minus x for x, do I get the negative of the function? Well, is this the negative of this?
No, because the negative 12 part is still negative 12.
Correct. If I put a negative sign in front of the numerator here, I get minus x squared plus x plus 12. So this is not odd either. So it's neither even nor odd. Certainly doesn't have y-axis symmetry because it would be even if it did. And it doesn't have origin symmetry either.
So it's
yeah, so you know what origin symmetry looks like? Here, I'll draw a function that has origin symmetry. That function is y equal x cubed. And actually, origin symmetry you get if the function is odd. Okay? Notice that if I plug in minus x here, well, I get y equals minus x cubed, which is minus x cubed, which is the negative of the original function, correct?
Yes.
So I could say that f of negative x is equal to negative f of x. That makes it odd, and odd means symmetry about the origin.
Okay.
So had this been odd, well, B would have been correct, but it also would have meant there's symmetry about the origin. So we kind of know that B can't be correct, and it has to be the last one there. So the y-intercept, let's see, let's go back to, we never did graph this. Oh, man. I don't know how to go back here, but I guess I don't need to, because the only part we graphed was that y equal x plus 4, the slant asymptote. Now, what is this thing going to look like? Wow. Well, the y-intercept always comes when x is what?
0.
So what is it here?
0.
No, plug in 0 for x into the function. And what,
negative 12 over negative 5.
which is?
12/5.
Okay. That's the y-intercept. 12 divided by 5. And find the x-intercepts. Well, the x-intercepts, where are they going to occur?
Where y equals 0.
Okay, so I'm going to make 0 be f of x, and I'm going to solve this equation. How can that be equal to 0? What has to be true?
X has to be 5 then.
No, that makes the denominator 0. I need this to be 0. If the denominator is 0, then I'm violating the first rule of math. I'm dividing by 0. Well, I don't want to end up, when you divide by 0, you basically get infinity, not 0. In other words, 2 divided by 0 is pretty much infinity. 0 divided by 2 is 0. Okay? So the only way this thing can be 0 is if that numerator is 0. So I merely have to factor the numerator into x minus 4 times x plus 3, and that's the only part that I need set equal to 0. Where does that happen? When x is equal to 4 or when x is equal to minus 3. They probably need you to go left to right even, I bet, huh? All right. Well, it's a little past 9. So, you good to go? You think you can do the last 2 in your own?
Yes.
Or the last?
Yes.
Let's see. Do we want to finish this last part up? Find the vertical asymptote.
Could we just finish this last part?
Yeah, sure. Where's the vertical asymptote here? Still there? Hello?
I think I lost connection.
Okay, well, we can finish this up by phone, but the vertical asymptote is going to be wherever the denominator equals 0, right?
Right.
Which is x equals 5. Yeah, I'll go ahead and put that in. And let's see if there's a 8th part to this. Yes. Find the horizontal asymptote. Well, there is none. Right?
Right.
And finally, pick the graph. Well, there's a vertical asymptote. Can you still see my screen?
Not anymore.
Okay.
It's frozen.
So you, okay. Let me pick this one. We have a vertical asymptote and we have a slant asymptote. And the only question is which quadrants I'm in. Are they 1 and 3 or 2 and 4? Let's see. All of these, hold on a minute. Looks like B has to be it. Yeah, I'm going to choose B for you. Good. I think that's the end of that question. Yeah, okay. So the only two you have to do are 19 and 20. Now, I should push save here, correct?
Yes.
Okay, I'll do that. And then I'll log out so you can log in and do the last two on your own. Yeah, I guess I just close out that. Yeah. Okay.
Thank you so much.
Yeah, you're welcome. And you know how to proceed from this point, so I'll let you just schedule whenever you need a session.
Yeah, I really like the online.
Yeah, it's nice, isn't it? It really is. You don't lose anything. Every now and then you have a glitch, like if you get disconnected or something, but it's pretty good. It's pretty good. You just don't really lose anything. And I have recorded this. Let me stop that recording.